Now today we are going to talk, let's get back to our class front page, okay? We have spent about a month, right, in a basic R programming, right? Now, beginning from the what is programming, right? We say programming is actually just a sequence that use expression to define and update data object, right? It's just a sequence to define and update data object by expression, right? Just so programming is easy. It's what just one sentence, isn't it? Now, what make it complicated is that first of all, the data object has many different types. They have different structure. They have different value types, and different structure, different types need to be calculated in different way, right? That is one complexity. And the other complexity is actually the expression can be very complicated, right? The expression is composed of data object, operator, and function calls. But they can be combined in like virtually infinite number of ways, right? So this is two things that make programming complicated. But we don't need to understand all of the complexity before doing programming, right? So up to this point of time, you should already do a lot of programming in this class in your assignment. The three things that we need to emphasize before I start today's content is that among all of the function code, some of the function code are easy, right? They simply like produced result, right? You give the function code input, and then after calculation they give out the output, right? So that is the function code. But there are three function code that is particularly important in basic R programming, right? Can anyone want to guess what is the three most important function code? Actually, we spend most of the last two classes in these three function codes. When you do your homework assignment, most of the time you are using these three things. Okay, anyone? Louder, please. Table, right? Table is the first thing, right? You want to count the number of different value in a variable, right? That is table. What is the second thing? Louder?
Summarize.
No, not summarize.
Histogram.
Which one?
Maybe graph or histogram.
No, not histogram. We have a function that do a group computation, right? Like I want to compare the average number of appearance of blue-eyed characters, things like that, right? I want to calculate the average arrest rate in all of the car stolen events in different locations, right? You want to calculate something based on groups. What is that come? Yeah, t-apply. Dplyr is the thing that we want to learn today, right? But before today, t-apply is a very important function code, right? What does it do? It do a group computation, right? The reason that you want to do group computation is what you want to do group comparison, isn't it? Right? I want to compare the by location the arrest rate of car stolen events, isn't it? Right? I want to compare by gender the ratio, the proportion of good character, right? So you want to compare. If you want to compare between groups, you will use the function like tapply. And what is the third comment? It's kind of like a sister comment of tapply. It's used to do repetition, to do iteration, right? it's also sum apply, right? but not tapply, right? It's another type of apply. Is to apply function to a collective object. Remember that? Right? You want to apply a function to a list of data frame, right? Do you remember the stopwise example? Right? In the stopwise example, we have a list of data frame, and we apply different function to the data frame so we can do different things, right? So you don't need to write program for each of the sub element inside the list. You simply right, do what? What is the function called? To apply a function to a collective object, such as list or array. L apply, right? It's L, right? L apply, right? Because it apply function to a collective object, right? So the result will be a list, isn't it? When you apply a function to each sub-element, you will have a lot of output, and you want to put that output in an object, right? So that object will be a list. So you call L apply, right? So this is the three basic things that after you actually, if you can use three things very fluently, you are already a very good R programmer. I can say that, right? So as long as you can use these three commands, these three function code fluently, you're already a good R programmer. And you actually have a lot of exercise in the last 2 weeks, okay? And starting this week, actually starting the homework assignment of last week, right? You are doing the homework assignment of this package, right? dplyr, and this package is designed for data frame manipulation, right? As its name suggests, it's for data frame manipulation, and that is what we are going to deal with this week. Okay, you already have do a data cam classes, right? For dplyr, isn't it? Let me see. I put it as last week. I forget. Yeah, this is a personal assignment, right? So let's see. Oh, sorry, it should be yeah, right. How come we do not have a folder to upload to upload the certificate? So where? Oh, sorry, it should be in the certificate. Yeah. Right. Yeah. Okay, so everyone already finished the course, right? So do you have any question when you do this class? Let's do it this way. You already finished the DataCamp online course about dplyr, right? So you should have some basic idea about how to use this package for data frame manipulation, okay? So a package is actually a collection of function calls, right? So in this dplyr package, there are a set of function call to help you do the data frame manipulation easier, right? to facilitate data frame manipulation, isn't it? Right? So actually, because today we have a shortened class, so what I can do is like walk you through the what you have learned in the data chem class quickly, and then we want to answer one question. When you do the data chem class, you might have a question about it. For example, like group by and summary, right? Whatever group by and summary can do, you can simply do it with dplyr, isn't it? The group by summary, if you put it together, it is actually a dplyr, isn't it? Because they are grouped by something and then do computation, isn't it? Right? So whatever dplyr package can do can also be done with the basic function code that we already learned, right? So why should we have a dplyr package, right? And that is the question that I want to answer in an hour, okay? So I believe that you already learned how to use dplyr, but why should we learn dplyr, okay? I will hold this question, and then we will answer that at the end of this class, okay? Now let's take a look at our outlines today. Wait a second, let me make sure that I do the recording. Okay, so we have actually 3 notebooks, so we need to go faster. And the first thing is the introduction to dplyr, and this is actually you already learned in the data chem online course, right? So I just walk you through and make sure you do not have problem on this basic commands, right? And then the second thing is group operation. It will need some explanation because the group operation is not well explained in the data chem class. Okay, so we'll spend more time on talking about group operation. Basically, group summary and group mutate. They are different things, and they are something that need to elaborate it, right? So this is the second thing. And then I'm giving you the data that we are going to use for our final presentation. So this is actually the Tafan data set. It's the data set from a retail store. It's the transaction data from a retail store, right? So we are going to use this data set the whole semester, okay? And at the end of the semester, we will have a group competition. Okay, we will have a group data competition. We will use this data set, okay? So I will use these data sets to demonstrate why we need to learn a package like dplyr, okay? So I'll spend more time on Unit 5B and also spend some time on the Tafan 01, these 2 data sets, right? So if you go to today's download directory, you will see like 3 things. Now, first thing is today's PowerPoint, but you should already know that I seldomly use PowerPoint, right? So our major material is actually in this 05 dplyr.zip, and then there's a tafang.zip. So after you download the things, you should put it this way, right? You should have a 05 dplyr, and you should have a directory called tafan. They should be placed in the same label, okay? So today we are doing this. Okay, here is the the file that we are going to get started. And then this is the defunct data set, right? It will go, I only give you the first two notebook, but it will get longer and longer along the way when we learn more and more, okay? Okay, that's the preparation. Let's go to our first notebook. It's this one, right? Introduction to the dplyr package. So in R, a package is basically a collection of function code, right? So with that set of function code, it extend the functionality of basic R, right? Okay. Now every package will have a main purpose. The purpose of dplyr package, is to do data frame manipulation, okay? Because data frame is so important, right? So so this package is try to facilitate the manipulation of data frame, okay? So as I say, they are a set of functions that help you do the data frame manipulation, okay? But first of all, we need to read in the data, right? Okay, because the data is in this format. When the data is in the .rds format, you need to load the data with rrds, okay? So we read the data and put it in the data frame called D, right? Now, if you take a look at the class of D, the data type of D, it is actually a data frame, right? But beyond data frame, it is also a table, right? So you can you can think of it as a enhanced data frame with some enhanced capability. Okay. Most of the time you just use it as a data frame, right? But it has some enhanced capability. For example, you can do the glimpse on a table, and that table it will give you like the number of rows, the number of columns, and this is there are a lot of columns, right? What is this data? This data is actually in your data chem class, data chem online class. So what is this data? We have 3138 records, right? So each record is what? Yeah, it's observation, but what is the subject? What is the unit that we are investigating? No, this is not people. As you can see, this is... Yeah, this is census data, right? So actually, do you still remember the online course that you just completed? This database, this data set is called county data set, right? Still remember that? Because every record represents a county in United States, isn't it? Right? So as a total, we have 3,100 county in United States, right? And every county, they would see, they would be inside of a state, right? Right? So this is the state name and county name, the region, right? Isn't it? And then we have a lot of variable, and this variable is the county statistics, isn't it? It's for example, this column called metro is specified whether this county is a metro area or it's in the non-metro area, right? Population, right? The number of people in this county, right? The number of men in this county, the number of women in this county, isn't it? Right? So every record is a county, and every column is an attribute of the county, right? This is data frame, right? Every record is a subject that we are going to investigate. And every column is a variable that attached to each of the subjects, isn't it? And in this way, and this is the common way that we gather our data, that we organize our data, and it's called data frame. Right? And dplyr, they give us a set of function call that we can manipulate data frame easily, right? Okay. Now the first thing is called select, right? So you can select because D is a very large data frame, right? It's very difficult to do to demonstrate. So we like just select the 1, 2, 3, 4. We select these 4 column from this D data frame, right? And we put it on a smaller data frame called D1, right? So this D1 only have 4 columns out of D, right? So select is easy, right? And then the second function is called arrange. Now arrange is to what? Is to do what? Is to sort the data, right? Is to sort the records by something, right? You want to do the sorting, you have a key, right? With what value you want to sort with, right? So we can sort with like population, we can sort with the like employment ratio, we can sort with everything, right? By default, the sorting is like ascending, right? It's in ascending order. If for some reason you want to do it like descending order, you will need to write this way, right? If I want to sort D1 by descending population, right? I will need to write this way. You already learned this in the data frame online course, right? So let's go faster in this section. So okay, we can arrange things like this, right? Now you should consider. You may think of a question, right? You might have a question here. Say when we do select, actually we can do like indexing, right? If I use indexing, I can use the angle basket, and I can also do exactly the same functionality, right? Isn't it? When I want to do arrange, I can actually use order, right? Right? With order and with like indexing, I can accomplish the same task without dplyr, right? But as I say, that dplyr is that they have some advantage, right? And we will summarize its advantage, its benefit later on, okay? Now the third function is called filter, right? It's to select the roles, right? So for example, I want to filter out the state equal to New York, and I think this is the percentage, right? Unemployment rate is less than 8, and then I want to like I want to, after the filtering, I want to arrange the output by the descending order of population, right? Okay, so the result is actually still a table, still a data frame, but this data frame is only have 39 county, isn't it? Because we only want the county in New York State, and the unemployment rate is less than 8, right? We have this condition, so we do filtering, isn't it? Right? Now after filtering, we do the arrangement, right? So this is the benefit. This is one of the benefit of dplyr. It is very similar. It's very similar to human language, right? You have a data. You want to do some filtering on that data. You want to arrange the data in some order, right? So it's kind of like human language, right? So when you can actually build a data processing pipeline, right? Okay, by using this dplyr function call, You can build a pipeline to process your data. And the way that it processes the data is very intuitive, isn't it? Right? Unlike like dplyr and dplyr, that type of thing is they are powerful, but it's very easy to make mistake, right? But you write this way, it's longer, right? But it's clear, and it's similar to human language. So you can do it like maybe it would be it would not so easy to get confused and make mistake, right? That's the purpose of dplyr. Okay. Now, what does this function do? Mutate. It is used to define a new column, right? Mutate is to define a new column. For example, if we want to define a new column called unemployment rate, so you define a column with an expression, isn't it? Right? With an expression of the other column. You want to define a new column, right? So you have to define it with the existing column, isn't it? Right? So that is the way that we do it, right? And then so this is mutate. So this is actually the benefit that of dplyr, right? It's similar to human language, right? So it can create, select several variables. It actually, inside of mutate, you can mutate a lot of variables at one time, right? So, and after that mutate, it's still a data frame, isn't it? So inside a dplyr pipeline, the output of every function code is a data frame. It's still a data frame, right? So with this unique data type, you can actually assemble a data assembly line, right? The data pipeline to do a very complicated things in an easy to understand way, right? Let me say it again. So dplyr is a thing that help you to do a complicated data process, right? In a data pipeline, right? So and in an easy to understand way, right? That is dplyr, okay? Okay, so let's see more. Let's see more function on the dplyr, right? Okay. Now this is there's a function called count, right? Now count is very similar to table, isn't it? Right? If you count a data frame, it would simply tell you the number of rows in the data frame, right? But if you count a column, if you count a column in the data frame, it's exactly like table, right? Isn't it? It simply count the number of rows in each state, right? It simply count the number of county in each state, isn't it? Right? So it's exactly the same when you do like table d state, right? This function is exactly like this, okay? But count has a lot of enhanced functions, okay? It has some enhanced functionality. For example, you can put on a weight argument inside count. So what is this expression do? Let's give out a gift. Do we have okay? It can't state, right? It can't state. So it's basically doing something like this. But it is not just only count the number of county, right? It has a weight on population, and it also do the sorting. So what is this expression do? What does this function call do? What is its output? Right, they sum up the population of all of the county in a state, and then sort it by descending order, right? So with these two arguments, count would become a very, very powerful tool, right? Okay. It count the state. It actually kind of like sum the population of every county in that state, and then do sorting at the same time, right? So use this count function will give you a lot of convenience when you do data processing, isn't it? Right? Okay. So it's very handy, right? Count is a very handy function in dplyr. And then there's another thing we call summarize. Now summarize is to like, it is used to to do a summarize function, to apply summary function on a data frame, right? For example, if I want to sum all of the population, I can do it this way, right? I call a function called summary, and in this summary function, I define two variables, right? The first variable is called total population, and it's defined it as the sum of all of the population, right? The second is called average population, which is the average of population, isn't it? Right? So within the summary, you can define some summary statistics, right, in a variable. Now, take a look at the output. The output is still a data frame, right? It becomes a data frame of one column and of one row and two columns, right? Isn't it? So every variable that you defined it within summary becomes a column, okay? So when we do summary on the entire data frame, you will have only one record, right? But if we group by, for example, I group by state and then do a summary, then actually I will see, right now I'll have, the output will be a table of 50 rows, right? Why? Because by this group by function call, I actually put on a group structure on the data frame, okay? The group by function call actually attached a group structure on the D data frame, right? So when you have a group structure on the data frame and you do the summary, you do the mutate, the following function call after the group by would actually on a group basis, which means that each group will be summarized one time, right? They would do 50 because we have 50 states, right? So this summary will be calculated 50 times, one on each state. Depends on what you group by, right? So usually you group by a categorical variable, right? So every group, they will be summarized once, and every summary will produce a record, isn't it? Right? So when you do group by summary, you will actually produce a data frame, and the number of row is equal to the number of group, right? And the number of column will equal to the number of variable that you defined it within your summary function call, right? Isn't it? You should already learn this in your last week's personal homework assignment, right? I just walk you through again, right? So actually this good summary is very similar to dplyr, right? Isn't it? like it's like I do t-apply on population, right? And I apply by state, right? I apply sum to population by state. I apply mean to population by state. So you can also do this by t-apply. But if you do it with t-apply, then you will need to write two lines of comment, right? You need to write 2 lines of code. And the output will be 2 separate vector, isn't it? If you do it by t-apply, you need to like write 2 lines of code, isn't it?
So for the apply, you will not show like for the apply, you will not show like the table. If it like if you show like in the table.
In the table.
Yeah, like the like this dplyr it show like a table.
You want to group the output of t-apply into a table. Is that what you mean?
Yeah, I just think like what is better to use.
I did not get your question very well. Can you explain it?
I mean, like because you said it's similar, right? So what do you think is better to use?
Why is better? That's what I'm explaining now, right? So if you do this, if you do these things with t-apply, right? You need to write a t-apply to summarize, to sum the population by state, right? That will be 1 line of code, okay? And it will produce a vector, isn't it? Right? And then you do a t-apply to do a mean on population by state. It will be another vector, isn't it? Right? Then you need to write the 3rd line of code to put these 2 vectors into a data frame, isn't it? Okay? So
like dplyr is better to like it show the data in the
right. The one of the benefit of dplyr is it always output a data frame, right? And you can actually summary a lot of variable within the summary. Let me jump to the 3rd notebook. You will see an example. Like I tell you, like this TF1. This is the 3rd notebook. Okay, it is. It is this notebook. Okay, this notebook, the 3rd notebook. So TF, this data set, as I told you, it was actually a data from a retail store in Taipei. Okay, this is the data of a retail store in Taipei. Okay, so the data it is a data frame. Okay, and the data frame has like 817,000 records. And every record represents an older item. You go to retail store, right? Every time you buy a lot of item, isn't it? Right? So every record is an item on a transaction, right? So you need to group the older item into an invoice, right? Into a transaction, isn't it? Right? And then every customer would have a lot of transaction, isn't it? So the data is kind of like 3 level, right? On the lowest level, when you get the data is in older items. So we have like, when you read the data, you will have like this many older items, okay? And then you will need to summarize these older items into order, right? You need to summarize the order into customer, isn't it? Right? So when we do the, let's see. This is the way that we summarize order item into order, right? As I told you, every time you go to a retail store, you will buy a lot of items, isn't it? Right? So if you want to group the items into a transaction, you will be interested in a lot of things, right? So you will summarize like the date, right? The customer ID, the age of the customer, the zip code of the customer, and then the number of items in that right, in that invoice, in that transaction, the total number of quantity, the total revenue, the total gross margin, and sometimes more, right? So usually in business analytics, you will have to summarize or you will have to mutate a lot of variable at once. Okay. So in this way, if you do it like dplyr, you will need to do right for each of these things, you will need to do a dplyr separately. And then you will need to build a data frame to like organize all of the data, right? It's not easy to do that, right? So using this group by summary is a lot easier to have you define a group of variable at once. Let me give you another example, right? This thing is actually to kind of like summarize the data for each customer, right? For each customer, the recency is like how long. It's actually the date that they for their last purchase, okay? And then this is the frequency, is the number of times he purchased from us, right? The monetary is the average transaction, the average transaction revenue, right? And then the total revenue, the gross profit, right? And so no matter what type of thing that you are calculating, in business analytic, usually you will have to like create a lot of variable on customer. You want to create a lot of variable on the company. You want to create a lot of variable on a country, right? On a region, isn't it? So dplyr make it easier to summarize or to create a set of variable in an easier to understand way, right? Isn't it? So let's go back to here. So as you can see, right now we only have 2 variable created, right? But think about it. If you want to create like 10 variable, then you'll need to do dplyr 10 times, right? And then you need to like put all of the output of this 10 vector into a data frame, right? It's easy to make easy to confuse and make mistake, right? But if you write it in this way, because the group by, you only have to write group by once, right? Isn't it? And the output of summary will be kept on a data frame automatically, isn't it? Right? So it make it easier. It make it easier to compose your data pipeline, right? So that is the major benefit of dplyr, right? Okay, it make it easier for you to define a complicated data processing logic. And trust me, in business analytic, the process, the business logic is always very complicated, right? So you cannot simply use the simple command, get simple function code like dplyr and table to accomplish that, right? So in order to do, to realize, to reflect the complexity of your business logic, a dplyr is a better choice, right? Okay. So that's the thing that we need to explain. Okay, so there's a thing that I want to explain more is about this group operation. Okay. Now, after the group by, you actually can do two different things, right? You can do group by and summary. That is very. I think the most common way to use group by is to use summary after the group by. So what the summary do is actually for each group, it will be summarized into one record, isn't it? I mean, if I apply a group by on this data frame, right? The different colors, different group, right? Because I group by year. So 2000 is a group, 2005, 2015. Each is a group. So when I put a summarize after the group by, it will actually do a summarize on each group, right? And the summary will become one record, isn't it? Right? So the resultant data frame is actually has the same number of records as the number of group, right? And you will have the column depends on how many variable you defined it within this summarize, right? So this is group by and summary, right? Now after the group by and summary, the group is no longer useful, right? Because every group is already condensed, is already summarized into a record, right? So the group structure will be removed after the summary, right? Okay? So there's a thing that automatically do, and you might not have noticed, okay? But if you do mutate after the group by, it's a different thing, right? You can mutate, you can do a mutate on the group by after the group by. But group mutate is a little more complicated, okay? Now, if you want to mutate, for example, here, I would like to mutate, after this group by, I mutate log n, which is apply log to n, right? This type of function, log, most of the numeric mathematical function code, the operators, they are what we call vector function, which means that you put in a vector to log, it will produce a vector of the same length, right? I mean, this type of function, when the output is of the same length as the input, okay, it's called a vector function, right? Put in a vector, it will produce another vector, but it would like apply log to every element, right? So produce another record. So actually, this type of function, you don't need to do it in the group by structure. Okay. See, I apply log group by group, which means I apply log on these two elements and put it here. I apply log on these three elements, put it here. I apply log on these four elements and put it here. Okay. You will need to do log 3 times, right? But the result is exactly the same as I do a log in the entire thing, right? This type of operation should not be done within the group structure, isn't it? It makes no sense, right? Because the result is the same, right? If I do apply a log on the entire vector, I only need to do the log once, right? But if I have to apply the log to each group, right? Sometimes you will have a lot of groups, right? In business analytics, if you group the transaction by customer, right? If you have like 30,000 customer, you will need to do this vector function 30,000 times, right? It will slow down your processing for nothing, right? Which mean that if you do group by and mutate, right? You really don't want to do a simple vector operation, right? Because this simple vector operation can be done on the entire data frame, right? And the result will be the same as you do it group by group, right? So vector function is not, usually you will not do this vector function. You will not define a variable with mutate with vector function. But there are two cases that you will do it, that group mutate is useful, right? The first thing is like, it's a vector expression with summary functionality, right? For example, if I want to convert the number into a fraction, right? So group by group, I would like to sum the n and as the denominator, right? And on the denominator, I put the n, right? So in this expression, I kind of convert the number into fraction, isn't it? And this convert has to be done group by group, right? Because the denominator in the first group is different from the denominator from the second group. It's different from the denominator from the third group, isn't it? Right? So when your expression has a summary function, you have a reason to do mutate within the group, right? It will be the different thing, right? If I apply this expression on the entire data frame, the denominator would actually be the sum of all of the n, right? It's no longer the sum of the group, isn't it? Right? So when you do group mutate, usually in the right hand side of the equal signs, you will have some summary function, right? Okay. And because the summary were different group by group, now doing group mutate will produce a different result comparing with doing it without group, right? Okay, so this is one reason that you want to do group mutate. Okay. You want to define a new variable based on group summary. Then you want to do group mutate. Okay, this is the thing. And the second case that you want to do group mutate is something like we call a Windows function, right? In data analytics, from time to time we want to calculate the growth rate. Right? Now the growth rate is something like I would like to I will have to shift the vector and do and calculate difference, right? So there is a function called lag. The lag function is something like I would change the position. I would push the vector forward or backward. Right, a lag is to push it forward in one position. Okay, so in that sense, take this as example. This value will come to here, and this value will come to here, and right. So after you shift it in one direction, then this thing will come here. The second will be the third. The third will be the fourth, okay? This is called Windows function, right? It means that if you put in a vector, it will also output a vector. But the resultant vector, the output vector would be shift in position, forward or backward, okay? So the reason that you want to do this is you want to do a kind of like, you want to calculate difference, right? In your data frame class, in the last section, as I remember, they are using a data set called baby's name. Do you still remember that? Baby's name, right? So in that baby's name, okay, see, this is the example of the Windows function, right? Leg is the Windows function, right? So let's see what they do here. You remember this data set, right? This is actually the baby's names, right? From the 1880s, from the year 1880s to the recent time, right? Every year they count the number of baby names, right? And then they so if I want to see the delta, right? I want to see the growth rate of baby's name, right? I want to see the difference between the time series. By the way, the time series is is exactly the topic that our guest speaker is going to present to us, like in the next hour. Okay, so if you have a time series data, from time to time you would like to do some operation like this. Okay. Time series. So this is time, right? Okay. So if I want to, for example, this is the revenue, right? For every year, right? Say, for example, this is the revenue per year. Then if I want to calculate the revenue, which means I want to see the difference between revenue, right? So I kind of like shift this time series like in one place, right? And then I do a minus, right? So then with this, I can produce the difference between this year and this year, right? The difference between this year and this year, the difference between this year and this, and define it in another variable, right? That's why that's the way that we use Windows functions, right? We want to see like this. I apply a leg on the vector this is the proportion, right? So I leg the proportion by one position and minus it and calculate the difference between the leg and non-leg vector. Then I will see a difference, right? I will see the difference year by year, isn't it? Right? So this is another way that we want to use. This is another way that we want to use the group mutate, right? Because in this example, we want to calculate for each name, right? The difference in year, right? The name's popularity, need to be calculated within name, right? So we want to examine how the popularity of a name, right, change year by year, right? Let me say it again. In this expression, I want to calculate how the popularity of each name, right, change year by year, right? So I have to group by sex and name, right? and do this mutate within the group, isn't it? Otherwise, I see the popularity of Mary cannot be compared to the popularity of like Cindy, right? Isn't it? They are different name, right? So this Windows function has no meaning when you do it like a closed group, right? So this is another type of mutate that you want to do it within the group, okay? Because the Windows function is only meaningful inside the group, right? So so in this way, this is another reason that you want to do a group mutate. So like group mutate, the two way to do group mutate is, first of all, you want to mix summary and vector operation within the right side of the equal sign, right? Because you want to mutate a variable that involve group summary. And the group summary has to be calculated group by group, right? That is one reason that you want to do group mutate, okay? And the second reason is you want to apply this window function. You want to calculate how a variable variate, right? The variation of population, the variation of popularity, right? You want to observe how one variable vary in times, and in that sense, we will use a expression like, you will use an expression like this, right? Where's the, like this, okay? You apply a Windows function to shift a vector, and then calculate the difference, right? And this thing has to be done group by group, right? Okay, so that is the second reason that you want to do a group mutate. Okay, now group mutate is different from group summary, right? After you mutate, the number of rows of the data frame is not changed. Because mutate is actually to create new columns, right? So it would not change. Okay. No, let me talk to her. Like, okay, so after you do mutate, the new variable should have the same length as the existing variable, isn't it? Right? Okay. So when you mutate, you actually need to have the expression in the right hand side of the function has to be a vector, right? Which means that if you mutate a new variable, now this expression has to be the vector of the same length with the existing, right? But if you simply just apply a vector function on it, it is meaningless, right? To do group mutate, okay? To make it meaningful, you actually has to like apply Windows function or summary function on the right hand side of the expression. This is one thing that I would like to explain. And the second important thing that I have to highlight is that after mutate, it actually would not change the group structure. Okay, the group structure because after mutate, the group structure is still there, right? You still have a different number of records in different groups, isn't it? unlike summary, if you apply summary on group by, right? Because every group has already been summarized into a record, right? The group structure will be removed automatically. But if you do group mutate, the group structure will remain, right? It makes sense, right? So it will not change the group structure. Okay. Now, because of time, I have to stop here, right? Okay. Now this is what we are going to do. Let's go back to here. In this week, I actually give you 3 notebooks. Okay, I give you 3 notebooks. So with the knowledge that you have already learned from the DataCamp online course, and the thing that I told you in this hour, right? You should be able to do this notebook by yourself, right? Actually, this notebook I already do a lot of data preparation for you, right? Okay, I told you that this is actually a data from a retail store, okay, and the raw data by itself is actually every record is an order item, okay? Now, in this exercise, when you prepare this data, you need to aggregate, you need to summarize the order item into orders, okay? And you need to summarize orders into customer, right? So we are actually applying what we have learned to a real business data already, okay? You might not be able to understand all of the steps that I have done here, right? So to utilize you can utilize the TA sessions, right? We have like 2 TA sessions, right? Friday afternoon, and also Wednesday night, right? Okay. So your assignment this week is actually a group assignment. I want you to like complete the notebook and then knit and upload it to your group folder, right? Well, actually, you don't really need to write a new code, right? I just want you to get together and try to understand, right? Try to understand what we have done in this notebook. And knit the notebook and upload it to your group folder, right? As your group assignment, right? I just want you to get together, take a look at the data, right? And then apply what we have learned to the data. Try to use the dplyr to process the data, right? Okay. And then, so next week when we're back, we were have a better understanding before we moving forward, okay? Now, it's 10:22, and let's take a break now. And after the break, we will have our guest speaker doing a a speech for you. Okay, and we will go back to what we stopped last week and continue on the dplyr package. Okay. Now let's take a break, and please be back in 10:30. Okay.